to another webinar about post-processor, and like in a previous one, we will continue with explaining, how to correctly handle some of the post-processor parameters, how to use them, and how to correctly input it and implement it in your post-processor, right? And today's topics will be about, how to handle correctly access vectors and orders there. It's the parameters and about from the VMID. Also, what very frequently asked question, how to define correctly device and submachine coordinate system. Why we actually have it inside our VMID, and and what is behind the scenes. What is the machine orientation parameter inside VMID? First, axis angle interval. I'll say one of the. It's not the most important, but I'll say second most important parameters for all 5-axis machines. And also here we have something regarding to new things in our GPP tool. It's like how to use the arguments inside the procedures. Then how to insert the drill cycles, where I will show you how to handle it, through the VMID and the GPP tool, and how to output the G code with subroutines and what kind of subroutines actually we can support today in SolidCAM. Okay, so first of all, I will start from explaining, all regarding to the axis vectors and how it's, the most. What is the correct way to implement that inside the VMID? As you can see here, I'll on the picture on the left, you'll see that we have some regular 5-axis machine that where the both axis, rotary axis, are on the table, and also not just the rotary axis. I will also explain it about linear axis, how to implement that. So I'll just very quickly jump into my SolidCAM and SolidCAM project, and what I'll do here, I'll just immediately jump to my VMID file. As you can see here, I can very clearly see the machine in a SolidWorks environment, and what I'll do here, I already mentioned it in previous webinar, every VMID needs to have at least 2 devices. That's the spindle and the table. The spindle is the device where the tool is mounted, right, and the table is the device where the part is mounted. Now, very frequently asked question is, okay, we've seen it so much time, and many times in the past, you maybe see why we have here minus and why we have here plus. We come to so many questions, how to handle it correctly. Now, I will say one general rule, and I will explain why it's in that way. First of all, whenever you have an axis that is on the spindle, the axis should be always positive. So as you can see here, I have the X and Z linear axis on the spindle, and it will be like, the X, it's X vector, and the Z, it's Z vector, and you can see that both are positive. Now, if you go to the table, Y, it's negative, A, it's negative around X, and C, it's negative around Z. Now, you may ask, does this influence, to the G code? I will say, regarding to the linear axis, no. So this is only for the machine simulation. Okay, so in everything, it's regarding to the machine simulation. Now, also one very nice and trick about how to choose correctly axis vector and correctly implement it inside the machine simulation as well is to follow the picture on the left bottom here. Maybe some of you never put so much attention, but check it out. Here I have the regular 5-axis machine where the A-axis, it's actually the limits are from minus 120 to plus 30. Now, if you see here the minus, the axis vector, this is like here is the operator, and you are watching the machine from the front. This is the x vector, y vector, and z vector, right? The positive rotation, it's here, it's represented as a clockwise, right? So this machine can go clockwise 30 degrees and counterclockwise minus 120. What will happen if I'll just change that? You can see that if we change the axis vector here to the positive, now my positive rotation will be counterclockwise, and the negative direction will be counterclockwise, right? Sorry, clockwise. Now I'll just jump into the negative here. I'll just here very quickly show you the machine that I have in front of myself. It's the machine that I just now show you. It's regular 5-axis table OKK, and I'll just quickly use here one of the views, and I'll just immediately jump into the right side, right? And pay attention here. As you can see, this is the front side of the machine, and here is the global coordinate system orientation, right? And this is the x, y, and z vectors. Now, if I go to the right view, you'll see that our x-axis is going toward us. Now, this is like just general, but just to show you that this is correct way how to define it. Here I'll put this to 0, and as I said, that if you have the minus vector, the positive direction, it's going to the clockwise, and negative direction is going to the counterclockwise. So if I now move it, you'll see that he's rotating in clockwise direction. If I move it to the negative direction, this is a counterclockwise. So in that way, and this really makes sense, because in the most of the cases in 5-axis machines, you actually want to be sure that the operator can see, you know, what it's going, what kind of operation is going on. In most of the cases, you'll never use, you know, another angle. At least you will try to not use it. But sometimes there is also needs for that. I'll explain that later. So this is why you have to use, you know, the negative value for the rotary axis. Now I also mentioned actually about the y-axis negative value. Now let's jump into the project itself, and it will be much easier to explain that. So I'll choose just simple regular operation, just to jump into the machine simulation. And great. Okay, so what I have here, it's just simple regular operation that where the tool is here, and it will help me, you know, to explain you why the y-axis should be negative. As you can see here, if I zoom in, you can clearly see our coordinate system of what is inside of the SolidCAM. Actually, our Mach 1 position 1. Okay, so and let me just jump into the x0, y0 position. So my tool is just right beyond my coordinate system, and in order to move my tool in the positive direction, as you can see here, I'm moving toward the positive direction. It's going very well. But what's happening with the table? If I zoom out, all the devices, actually the whole table and all the geometry, is actually going in minus direction. So it's pretty. This is pretty basic things, but you know, I think it's really explaining, you know, how and why to implement the axis and axis name and axis vectors and in which direction. Okay, so and now I'll talk about what about axis orders. And probably many of you knows that we are supporting 5-axis machines very well, where each the 5-axis has 3 linear and 2 rotary axes. Now, depending of where those 2 rotary axes are, there are we have actually 3 types of 5-axis machines. Then we have the table, we have the head table, and head. As you can see here on the bottom, here we have the table, the kinematic, because both axes are actually on the table. Here we have the head. Both axes are on the head, and here we have the combination of those two, where it's the head table, where one of the axes is on the head and another one is on the table. Now, respecting to our submachine, regarding to which devices will be our pair, we need to define what are the linear axes that we are using, and what are the actually the axis that we will use there. And there is the critical and exact rules regarding to what is the first rotary axis and what is the second rotary axis. This is very important if you want to get correct output into your G code. So so let me start first from the head kinematic, where my first rotary axis should be always independent axis, which is the C axis on the picture, and the second rotary axis should be it's actually a dependent axis. Now, what is independent and what is dependent axis? If you take a look here, the C axis, it means it's independent. Now, to better explain you what means independent, I will start actually from the A axis. If we rotate the A axis here, it means it's independent. Why? Because the position of the tool and the C axis, it's not moved in that way. Now, if we start to rotate the C axis, which is independent, the A axis will spin as well with that. So this is the way how you should always think about it. Regarding to the head table kinematic, the first rotary axis is always on the table where the part is mounted, and the second rotary axis is always then on the spindle. Here it's very easy to understand what is the first rotary axis and second rotary axis. And on the table kinematic, it's totally opposite what we have on the head. The first rotary axis is always dependent axis, and second rotary axis is always independent axis. Because if we rotate the A axis here, the C axis will follow. The axis vector will always, change the position in that. Okay. Now we are coming to the topic like device coordinate system and submachine coordinate system, and why we need inside our VMID, why is that important, and how to handle it correctly. Now, many times I get the question. This is usually happened when you want to when you convert VMID from last version to the newest one. We implement a lot of things, and you will now see why this is very important, and it will be very clear to you. The message here on the left side, it's very frequently asked, why we are getting it inside our VMID, and it's like coordinate system position of the spindle should be located along the B axis. Now, if one of your devices has, and in this example, I'll explain about the turret. So if the turret has at least one rotary axis, that device coordinate system position should be the same as the rotation point of the rotary axis. So here on the bottom picture, on the bottom right, you'll see one head table configuration. Right here, this is the table head, and here we have the pivot point, actually the point from which is the rotation point of this device. Now, we need to implement our coordinate system right in that point. Now, the question is why? The answer is it's because SolidCAM wants always to calculate, are we inside a linear axis limit of the machine? In order to get correct limit error while you're generating the G-code. So before you even go to the machine and try it there, you are getting the error message before. So that's the purpose of it. Now, also, as you can see here, we have also the coordinate system of the station, and this is coordinate system of the turret. So you need to put it in correct place. The coordinate system of the station is basically related to the coordinate system of the turret, and it's the position where your tool is mounted, right? Where we have also the holder and the H length and tool and everything here. Okay, this is regarding to the head table. And here I have another example when we have a head. Many of you asked this, and what is the rule? Now, the rule is very simple. It's the same thing as in the previous, where the rotation, where the coordinate system position should be in the rotary point of the second rotary axis. The same thing is on the head. The coordinate system should be always along second rotary axis. Okay, just follow this rule and you will never have any mistakes. Okay, and you will never get any error message. Now, here, as you can see, the main reason why we are doing this is even when you're rotating the second rotary axis here, the pivot point position here, it's not changing at all. And in this way, it's very easy then to calculate all the axial limits, you know, that are you inside or not. So this is the reason why. Now here, as you can see here, we are along the second rotary axis here. Of course, in this example, it's also in the same direction as the first one, but really doesn't make, it's not so necessary. It's just really important to be along second rotary axis, and that's it. And also, here it's also the position of the coordinate system of the station that needs to be related to the coordinate system of the turret, and you need to shift it here. Now, regarding to the coordinate system of the station, together with coordinate system of the spindle, we are coming to the topic of submachine coordinate system. And all those three really affect would you get correct axis limit error while you generate the G-code? Okay, this is all about. Okay, now here what I have on the left side, it's just regular 5-axis table machine that you see previously, and many of you ask, you know, what is actually the submachine coordinate system? And generally, in SolidCAM, you need to define where it's your tool mounted and where it's your part mounted. We are now in the previous slides, I explained you where the tool is mounted, right, and where should be the coordinate system of the turret. But the submachine coordinate system actually it's the position where the part should be mounted. Actually, the machine setup where should be calculated what is the real location of it. When you when all those parameters you merge it, you will get correct limits if you correctly put all the data inside. Now let's jump to the one of the many questions, you know, that resellers are coming. It's okay. So I have how should I set up the VMID in order to get correct machine simulation? You know, in the past we have, you know, just made the spindle to the table of the rotary axis and put there your global coordinate system. So this was the rule of in the past, but really today SolidCAM becomes implements actually the very nice options. And today there is no limits regarding to where you should put, you know, your STLs and your coordinate system. So here I put 3 most common types of how the STLs will be exported. So here I have the classic one, like I explained it. On the B, I have actually where the coordinate system of the STLs, it's actually on the table, but my spindle, it's actually on the top, where the tool change is happening. Actually, it's the reference point of the machine. And then we have another case where my global coordinate system is actually right where the tool is mounted, and where the tool in the tool change position, spindle it's shifted, and it's not on the face of the table, right? Let me just jump into that. Okay, so I'll just jump into the project, and I would like to show you, one of the tools that I'm using here is the 3D tool. It's a totally free software that you can grab on internet. It helps me, to open the STL data and to read all about, the measurements and basically to handle my VMID correctly to get correct machine simulation. Now this is the case where my global coordinate system is in exact position where my tool is mounted. Now I'll show you how to set up this correctly and get correct data. Now the position of this, let's see. Let's jump here. I'll open my VMID, and here I have devices. So first I will start from the spindle, where it's my tool and coordinate system regarding to the STL. As you know, it's the position, because my spindle don't have any rotary axis, right? I don't have to shift my coordinate system. And actually my station. So the coordinate system of the spindle and coordinate system of the station can be, in the same position. So coordinate system, it's in 0, 0, 0, right? And station, it's 0, 0, 0. So this is the position where the tool should be. Now let's jump to my submachine, where my part is loaded. I'll just click here, and here by default we have the vectors and we have the position at 0, 0, 0. If I save this, my part will never be on the table. My part basically and my machine setup basically will be calculated from that point. So I have to shift it in this position. So what I'll do here, I'll just hide my stock here, and what I'll do here, it's basically, I'll measure it. Here I have the measure tool, where I'll just click here, I'll just jump to my table, and I'll click on here on the table, and here I'll again click on the spindle itself. Okay. Very good. So regarding to that, now I'm getting the info regarding where it's my table face, where I would like to have calculation of my machine setup and where my part will be loaded here. This is the X, Y, and Z. Pay attention that this you'll get always positive. Okay, you need to take a look, on your position of and the rotation vectors. Okay, so 415, 530, right? So the coordinate system in this case should be changed. My X it's 415, and my Z, pay attention, it's minus 530. And now this is correct way. Now if another thing has been changed regarding to the A and C axis, now my rotation point, it's not 0, 0, 0, and the C it's not 0, 0, 0, but we have to calculate it. And where they are, you can use the same data here. For the A axis, it's just on the 530. Why? Because we don't need the x value because the a-axis is parallel to the x-axis, right? And the x value, it really doesn't make any difference where you put it, okay? So in this case, my a-axis should be minus 530, and my c-axis should be just 450. And now you completely finished everything. All the data, like the x, z, y, it's regarding to the coordinate system of the spindle, and also for regarding to the table, it's regarding to the coordinate system of the submachine. Okay. Now another question. Also, I'll just very quickly jump into that. It's what will happen if I'll just delete all this, and what will happen if I'll move my coordinate system here, like the second example that you get from the slide. So what I will do here, I'll select all, it's already selected, and I'll just do it again, just in case. Okay, I use the control, okay, and took all the geometry that it's inside this project, and there's very nice tool here. Let me just check it. Where it is, more tools. Yeah, here's the move option, and I will move it to 415 and minus 530. I hope that's no. It's opposite here, minus here, and this is plus. Right. So I will just show you now very quickly what's the difference now when you have the coordinate system right on the table, and your spindle, it's in the reference where you have the tool change position, where it's in the tool change position. So coordinate system, or where it's my submachine coordinate system, where it's my part, should be right 0, 0, 0. My a-axis should be as well 0, 0, 0, as well with the C. And now my coordinate system of the spindle, it's right located here, which is minus 450 and in plus 530. Okay. So regarding to the station coordinate system, it's regarding to the coordinate system of the spindle, and it should be 0, 0, 0. This is maybe maybe a little bit confused, but once you've done it and generate, the output, you'll pretty clearly see, what is the main difference. Now, regarding to everybody, how to generate machine simulation automatically, we have a very nice option to just right-click here, and you have export to machine simulation. That will create automatically all the structure of your machine simulation, where you will have just to implement your geometries. Okay, I'll just now exit. I will not save this. And now just the facts about all what we mentioned in the past. It's like if you correctly input your submachine and device coordinate system, you will get correct machine limits, error message while you're generating a G code. Now that will only happen if you put your parameter post-machine into yes. It's the parameter inside the VMID working style general, and here we have post-machine yes. About post-machine yes option, I'll talk more about it in the next webinar, but just for now, remember it that with this trigger, all the data from the VMID will be calculated, and it will be kinematic sensitive. Okay, this is just now into theory, but I will tell you more about that in the next webinar. Now, many of you are asking me, what's happening if the post machine is equal to no? How to get G code error message? How to be sure that we are inside the limits? Now, the answer is you cannot get it while you generate a G code, okay? But you can just correctly get it if you run the machine simulation. So inside the machine simulation, you will get an error message that you reach the limits and you are axis overrun. Okay. Now about machine orientation option. It's a pretty new feature that we add in SolidCAM 2015. It's, let's say, more regarding to the mill turns machine, and you can find it just inside of machine VMID. Okay, it's the very second parameter, and the main purpose of this coordinate system, let's say this option and this parameter, is to get correct orientation of your tool inside operation. So this window, let's say, so mini window here that we have in the operation, we get, we figure it out that sometimes it's not correctly orientated while we are, in front of the machine. So it's very important to understand how your coordinate system of the machine is orientated while you are in front of machine. So here I have the example, right? This is the regular 5-axis or 3-axis machine, 4-axis, no problem, where our Z is toward up, right? If you try to rotate your vectors, you will get, for example, in the mill turn, you will get different orientation, but the tool will be in correct position. Okay, so I'll just jump very quickly into that. I'll just use here the milling one, but it's just to show you, the most two common types what you will face off. This is the regular, and you should not change it if you have the milling machine, right? And if you have the mill turn, you just write the X. It's actually my Z. My Z is actually the X, and the Y-axis is flipped, correct? So some of you, if you are familiar with the mill turn, you'll know what I'm talking about. So my X, it's actually the Z. My Y, I said it's flipped, and my Z is actually X. Now, if you put correctly, you'll get the picture here, right? If you put something that is not visible, you will not get the picture. So this is one of the indicators. Did you define it correctly or not? So now you have the standard coordinate system of every turning or mill turn machine. Okay, and with that you will get correct tool orientation inside operation. Okay, I'll again exit. I will not save it. Okay. And now let's talk about the first angle pair interval. I'll say very important, in handling 5-axis machines. I'll say after the definition of the spindle coordinate system and axis vector and everything, I think this is the one of the very first, very important parameters in order to get correct angles inside your G code. Now, first of all, it allows you, to switch the angle pairs. And here on the left picture, you can see that, and also on the right one, you can see that where is the parameter. If you just click on the submachine, here you have the first angle pair interval, and just pay attention. This parameter is always regarding to the second rotary axis. Okay? So this is the limits of your second rotary axis, and it shows you, represents you, how to use it and how to switch it between each of them. What is the first? What is the second? Let's talk a little bit inside the CAM part. Okay, so I'll start generally to explain you about this a parameter and how to use it very well. So here, what I have is just regular 5-axis part indexing. Okay, it's not the simultaneously, right? But maybe you know, maybe you're not. But let's start from this surface that right now I selected. So in order to machine this surface, there is always two different angle pairs that you can get to the machine in order to machine it. So let me show you. First of all, okay, if I'm in front of the machine and I want to mill this surface, here it's my tool, right? It's vertical. In order to machine it, right, we need to rotate it around the X, and here is the X vector, right? And here I have the 5-axis machine. It's like around the X, and another one it's around Z. And to machine it, you need to rotate it right around the X in positive 90 degrees angle. Now this is the first angle pair, or let's say one of the angle pairs. And the second angle pair, how you can get it, pay attention. I will rotate it around the C axis 180, and then I will rotate it minus 90 degrees. And then again, we are getting to the same surface to machine it. So always in 5-axis machines, every surface can be reached with 2 angle pairs. Okay. Now the parameter, just the one that I show you now, it's to allow user to correctly define which side of the machine you would like to mill. You know. So let me show you what I mean really about it. So let's think in this way. As you probably know, here I explain you, about this machine and show you already this. And if I move this machine, this is minus 120. So everything from the 0 to minus 120, he will be able to do it. Now I'll put in this example the A-axis. It's of course in maximum limit of plus 30. But in this example, I will just put in the positive 120. Okay, and perfect. And let me just find some very proper, yeah. The second operation here, what I have, it's just simple face mill, where I would like to clean this surface. And probably many of you knows and solve this parameter. And by default, it's always in the first angle pair. And I play a little bit in the past, so it was just about that in the second angle pair, but generally by default it's always first angle pair. And remember this, first angle pair, and in VMID it was from minus 120 to 0. When I save that and load my machine simulation, I will be actually in my first angle pair interval. So it will be from 0 to minus 120. Here it is. So we are in this pair. Now what will happen if I go to the operation, just jump into the motion control and choose the second angle pair, save and calculate, jump to the machine simulation, and now you can see clearly that my table actually rotates to the positive 120 degrees. Now, many of you will ask, why this is important. Sometimes there's needs when you have pretty long part, and you reach your y-axis limits. You're not able to do it in the first angle pair interval, so you have to switch it there. And then to use it, because the y-stroke in another direction, sorry, y-axis in another direction, it's just, it's much longer, right? And then you are able to perform it. Now, that's pretty cool. And let's see what is happening inside the post. So I'll just jump into my trace, and I'll generate my trace for 5. Now, I already know and about what is the procedure, about where I should get it, but you'll figure that out, after it. So everything regarding to the work plane rotation, you will get in rotate to plane, and every first procedure every first variables are my first axis angle, which is 180, and the second axis angle it's minus 90. Cool. If we go to the second axis angle, no, to the machine simulation, my mistake. Okay. I'll generate the G code. And now I'm getting my first angle pair 0 and second angle axis angle, sorry, it's 90. So this is how to handle your 5-axis, indexing angles, right? And now it can come the question, what will happen if you correctly put here the first angle pair interval, and what will happen if I roll back my maximum limit to plus 30? And if I jump to my second operation and go to the motion control, switch the first angle pair, 7 calculate, generate a G code, go to my rotate to plane. You can see that my first axis angle is 180 and second axis angle is minus 90. Now, if I choose the second angle pair and save and calculate, generate the G code, generate it, trace 5, and just jump into that procedure, you'll see that the variable is totally same. It's because SolidCAM automatically calculates and check the VMID parameters. Are we inside the limits or not? If we are not, he will generate the only possible pair that it's define it inside the VMID. Okay? And this is pretty much about this parameter. I think it's pretty handy, and for you who didn't know how to work with, this is the way and all the theory behind it. Okay. Nice. Okay, so now we are jumping to something regarding to our GPP tool, to the Notepad++, and one of the, I'll say, newest functions that is added in our GPP tool. It's the an options for user-defined procedure to put with the arguments. Okay, so as you can see here on the left side, here is just the format. Okay, so it's very important that and in the first rule is you cannot use the procedures that are from system. Okay, so it's only allowed to use the user-defined one, and then you have some brackets, and here you can put any argument. So the argument can be variable. Okay, it can be some math function. It can be a lot of things, and I'll show you how to handle all those things from practical side. Okay, and here I have few of the examples and what is the valid and what is the invalid. So let's check it out. So here we have user ABS, and here it's numeric X. So even just before you put what is the argument here, this is just variable name like you are defining in the beginning of the post. You need to declare it what kind of variable type it is. Is it numeric? Is it string? It is integer, or it's logical? So you need to define it before. But pay attention, this variable here, you can just use it in this procedure. So this is the limit. Okay, but that's pretty great, because why we are creating user defined procedures is because you want that procedure to do some kind of the job and to exit from that and nothing else. Okay, now here we have like user, here is like lonely, it's just without any arguments. Now if you put the open and close, if you put open and close brackets, nothing will happen. Okay, it's the same thing like the previous one. And here we have like user test, and then this is the string A, numeric B. I will show you how to use that in one of the examples. And now here we have invalid one, where we have the line numeric. The first thing, you cannot declare system procedure, okay? So this is the line, it's system procedure, and it will not allow you to use that. Here we have user function and numeric expose. Now the expose variable, you can use it as an argument, but you cannot use it for declaration of it on the beginning. I will show you that later. And here you have user function like X. You need to declare what kind of type it's the variable. I'll just very quickly jump into the project and show you how to use that. I will start from really basics, okay? So and go a little bit maybe further. I'll open another project. Maybe you remember this one. It's from the previous webinar. And what I have here, it's another post. Actually, it's totally same post what we have in the previous webinar. Just on the bottom one, I generate one of the, let's say, user-defined replace string procedure. Now, the goal of this procedure is to replace some of the strings that we are getting from the system to something that is more, how to say, it's more friendly to the controller. Because if you put this kind of character inside of your controller, you will immediately just get other message, about the letter and the character, that is inside. So you want to be sure that all the strings that you are getting from the SolidCAM system, it's generated with something, that it's very user friendly to the controller. Now, now one of the reasons why we are doing that is, for example, here where it is, yeah, fee. What will happen if, for some reason, instead of D, okay, here from the SolidCAM, you are getting the D, I put the fee value. So you need to understand that this is not allowed character, inside your G code. So you want to be sure that this is not outputted and printed into the G code. Now let's see how to handle this. I'll just immediately jump to one and use this. So I'll just now save this and I'll just clone it. And on the left side, I will still use this procedure. I will not close it, but on the left side, I'll search for something that it's playable. Okay, I can use this as an example, but maybe, yeah, start of job. So on every beginning of the start of job, we are printing what kind of operation is this. What is the its job name? So I can just put not original job name, but I can just put job name here. And if I generate my G code, here it is. I'm getting, the character that is not allowed for our controller. And it will be totally fine, but not if you run it on the machine. So let's try to use these arguments. Now here I have the job name. So in the past, without this nice function with the arguments and the procedure, what you have to do is, in order to use this, you have to say, okay, my S replaced, it's equal to job name, and then, to that S replace, go call here, and then, to load on the bottom, and then to go back again, and then to print this S replace it. So it's like 10 blocks of the code that it's really not so necessary. Okay. So what I'll do here, I'll just jump here, and I'll call for this user-defined replace string procedure. Now, what are my arguments? So my argument here is, okay, it's when you open your bracket, and I need to declare variable that I will use here. So the variable that it's used here is as replaced, right? And what you need to do is just to put string and as replaced. Now every time when you call this, procedure, you need to put string variable as information when he gets inside of that, and that variable will be used later on inside the procedure. So we are calling here as replace, but before I do that, I will just go to my beginning of the post and I will delete this as replace. So one of the advantages here is that you don't need to declare it on the beginning of the file. It's necessary to put it here, and it's already declared, and you can use it inside the procedure. Now, as I said, if you're calling for user-defined procedure, you need, with the arguments, you automatically need to put all the parameters that this procedure is asking for. And my job name, it's actually right, but I need it. So my job name, whatever it is here, will jump here and will replace, let's say replace, or will feed the value, string value here, and then you can use it later here. Okay, so what is the results here? The goal of this procedure is to also to print out whatever it's in the brackets. So I'll put like new block, upper, and here instead of job name, I will just put as replace it. Perfect. What is the results? I can delete this one. Okay, so let's see. And one of the things that it's very good that to show you right here, it's that even if we do everything correctly, this will not be, it's not correct. Now, why it's not correct? Pay attention on this. This is, let's say, another level of the GPP. So every GPP file, every text file, pay attention on the encoding, on in which system you are. I'm recommended to always not use any of these, but to use ANSI. Look what will happen if I just go to the encoding and put the ANSI. So I'm getting some characters that it's not readable for this system. You see that? So what I need to do, all those, I'll delete just for now, okay? And let's say I'll delete also everything from here, so I'll just show you in this example, right? And here I'll put, let's see, I'll go to character map. I'll find it, let's see where it is. It's always a pain to find this. No matter. Let's select this one and use it. Oh, it's not possible now. Okay, so let's change and let's do it. This is usually it should work. Maybe I did some mistake, or but play with it. Let's see if I put here. Now it will remember. If I put here, okay, let's check it out. It will work or not. Still not. Okay, so let's put another example here. If I try to put another letter like let's say T, or let's say D. I'll put the D. Okay. This is the example. It's pretty messy, pretty not good example, but you know I'll just try to give you this info maybe on the next webinar, and I'll replace it with a smaller with capital O. Okay. So if I have now the D, I'll recalculate that. I'll generate the G code. Okay, and now the D, it's replaced with with O letter. Okay. Okay. Now another function and how we can use it, it's with a new block or with, let's say, without a new block. So I would like to just print it out here we have very nice like UDR message of the tool. So how we can use this? So for example, here as you can see, this is the difference. Here I don't have the new block, right? And here there is a new block. So I want somehow to tell my procedure that I would like to print it with and without. How to do that? So let's see that the first parameter should be always the string, and another should be like I don't know, it's like logical. Is it like with new block, for example? This is a good example. And of course, pay attention, it should be declared before. So I'll put here logical b new block. And here we can put, this parameter. It's very nice to put it like if new block is equal true, right? We will print it with. And if it's not, we will put without that. So I'll just simple copy place here, and I'll delete the new block. It's much easier. And then I'll do an and if. Now the only thing what you need here to do is like to call that user define, right? Call, let's put user define replace, and inside the brackets, right? You need to pay attention. This is another level, because now we have here two arguments. We need to put each one of them, inside the brackets. So another one, it's, the reason why we need to do that is because somehow we need to split those two, So this is the first one. It's the string, and it will be like tool message, right? Now you can use the semicolon. I think it's necessary. And here we need to put, is it a true or false? So I'll here put the false because this message is without that, okay? And I'll just close the brackets and I'll delete here what it's inside, right? I don't need it. Pretty good. This is one of the ways. Let's see how that affects on our first one that we just now declared. So here we have job name, and we need to put semicolon. Just the comma, and here I will put to false. This is one of the example. So my job name will be replaced with this string, and my false will be replaced with the logical. Pay attention that these arguments that are inside the same type of the variable that is in the first bracket, it needs to be same as the first argument inside the procedure, and as well of each other. So here we have the false, it's the information, it's logical information, and it's coming, here to the logical variable, right? So now we have the false, and now if I try to generate this operation, I'll generate okay, and now you can see that this it's printed into the previous block. If I change it here to true, it will be printed into a new block. Now this is one of the really basic, okay, and in the future of the webinars, I will just show for how to handle and how to use these arguments, in some of the cycles that is very important here. Okay, let's just jump here, and now I'm coming to very important one of the things, like how to define, drilling cycle. Each machine and each controllers, it depends, is it a Fanuc, Heinz, Siemens, they have different format of the drilling cycles, right? And they have, some of them are pretty same drilling cycle, like the regular drilling, peg drilling, drilling with the dwell and tapping and so on and so on, but they actually shared pretty same cycle with different format, right? And today I'll just show you on this post-processor how to implement and how to use the variables inside of the drilling cycles, okay? So here what I have, it's just simple, regular drilling operation, just 2 holes, very simple. And the reason why I haven't just, the 2 holes, it's because whenever I'm creating the post, I'm trying to not have huge operations, because with a huge operation you will generate a lot of codes that it's not necessary for you, and it's very hard to analyze it. So my advice to you, it's always use very short operations just to get correct format, and after that, if you want to analyze it better and to check are you correct or not, you can use even more geometry. So what I'll do, I'll just jump into my VMID, and to define a drilling cycle, you need to go to controller definition, right? And here you have milling drill cycles. It's the folder where you need to implement all your drilling cycles. So in today's webinar, I'll just add 2 cycles. One will be the G81, another one will be G83. The first one, it's just the regular drilling on the FANUC, and another one is just simple drilling with a pack. Okay, so the very basic what you need to know and to understand with the drilling, it's these 5 parameters. The first one, it's general user interface name. So this is parameter for the user. So this is what user will see. Okay. So here I'll put like G81, but you can put like just the drilling. Or also, it's very handy to put like this, and this will be here. For now, I'll not do it in that way. I'll just put like G81 and or let's say, why not, drilling G81, and here I'll put GPP name. It will be just G81. It's much shorter for me. It's better. My type is, of course, it's drilling here. And I would like to use this cycle as a default. So whenever I load the drilling operation, the checkbox for the drill cycle will be always yes. And here we have the custom picture. It's still not yet developed. It will be, instead of the system pictures, you will be able to implement any different, that you have. Okay. And for now, here I'll put another one. It's like a pack. I'll put here G83, and here I'll just put G83, and it's not a drilling. Here this is a pack. Okay, and would like to use this as a default, and I'll save it. I'll save and exit. I'll just jump into the operation. I'll go to my technology, and here we are. So this is the 2 that actually I defined it. So we have the drilling, and here I have the pack. Now I'll just jump into the drilling one, and let me just show you here what I have. I'll just go to the FANUC. This is one of the websites that I'm using. It's hellman.cnc. hellmancnc.com, and here you can find pretty good information about G-code, and here what I have, it's the FANUC of the FANUC's G83 and its format. Here you have a very nice picture, and this is the format. G83 X Y Z. R is the Z actually is the, here we have the depth, total depth. The R, it's position of the R plane. It's actually for the initial plane where the tool, this is the R plane, where the tool after the cycle will go. Okay. And here we have the Q. It's like what is your pack depth, and the feed. The K here is number of the cycle of the repetition. We will not play with that right now. Okay, so the G81, the difference between G83 and 81 is just with this Q, right? It's without the pack. The rest of it is totally the same. And here we have some G-code information, how G-code example, sorry. Okay, so let's implement that. And first of all, what I'm always do, I'm generating the trace with level 5. I'm pretty experienced with this, so I'll just immediately jump to start of job, because I know that everything starts basically from that point. And going towards the home, I'll delete everything. So I don't want to mess with everything. I just want to play with this, what I need. Also, the start tool and replace string, it's not so important for me. And the very first procedure is the drill point, again the drill point, end drill, and end of job. So for now, also the end of job, it's not very important for me, so I'll just delete it. Now, the reason why we have the 2 drill points is, we have two holes here, and that's why we are generating the drill point. Now I'll just very fast jump into the very important variables that we have, and then I will explain why we have so much different kinematic outputs here, like oppose, xh, u pose, and so on and so on. Okay, so first of all, the most important one is the my L pose here. This is the one that I actually need. This is the very first position of my tool. So if I jump to my toolpath, you can see it here. This is my position. This is my first point. So I would like to use that. This is from the drilling, and also very important one, it's my upper Z and my lower Z. With those two, I can declare what is my Z level and what is my retract, right? And then we have another drill points. It's I'll say also very important, where I can declare where is my first drill point and where is my second one. And here we have end of drill. Now, the third most important variable here, it's, pay attention, this is the first drill. Okay, it's equal. Is it a true or not? It's just indicator or the flag. Is it first drill? And you can see here the reason why I created the tool one. It's like this is not anymore the first drill. And I'll show you how to handle those three procedures, like end drill, drill point, and the drill inside just only one procedure. And I will use the drill point here because I have this trigger. Let me show you what I think about that. So the first reason it's where to put inside the post-processor, right? Now, there is no limitation where you can put it, just not to be inside of your procedure. So just put it wherever you want. It's like the drill point, NP. I'll just immediately close it in order to not make mistakes. And first, we need to bring my tool into the first position, right? So it will be like my G code will be 0 here, and then I'll print out my position. Now the position, I would like to print it just if it's a first drill, right? So if you can use also, copy paste, why not? If first drill it's equal true, then you want to print like the G code and the next position of your tool. Perfect. Now the reason why I'm not putting like this X and so on, it's the thing is I'll just here clone it. It's because on the really top my format it's already declared with my prefixes. This is what we are already talking in the previous webinar. So how to use the prefixes and suffixes inside your format options. Okay. And then here, right, one of the things that I didn't say, it's also one of the very important, is drill type. Now the drill type here, it's pretty handy, and there it's two ways. You can use like drill type, it's equal to 0, which means it's for the G81, or you can just use exactly what is the GPP name. So if it's equal to the G81, my G code will be 81. And you can also, like, if drill type, right, it's equal to G83, my G code will be like 83. And this is end if. And now here what I'm missing is if. And also here. Perfect. So now when I implement and put my G code to 83, now what I need to do is, of course, to print it out. So it will be let me check G code. Okay, it will print this one, and okay. So let's see here. I'll just put here else, and here if it's not the first position, I'll just print that exactly the same but without G code here. I'll explain that later why. Okay, so here I'll put like the G code. And what we need to do here, I'll just jump into the format. We have X, Y, and Z. The most important is the Z and R. It's the lowest depth and the clearance, right? So my Z will be, let's jump here. And let's use here, like, let's see, my lower Z. I'll use with the ZL. And I can use also the R value with my different variable drill upper Z. Don't worry about the XL. One of the questions you may ask, why I'm not using the X pose, Y pose, regular one. I'll explain that a little bit later. Okay, we have this, and that's pretty much of it, and it's fine. Let's see where we are now. So I will generate the G code. Click OK. Okay, so first of all, what I have is X, Y, and Z, and then we are printing in not correct position. So what we are missing here is new block. So this is the way how I'm doing it. It's don't try to be perfect, okay? Just try to create whatever you know for now, save it, generate the G code, run it, and and you'll check it out where you are, and then try to fix your problems. Again, I'll generate it, and okay, so we have G0 tool position, we are running it, and then we are getting the next position, which is not correct. Why it's not correct is because then it will bring my tool again to the initial point and not to the next position. How to handle these things? So if it's my first drill, it's not true, I don't want to print all those three values again. I just want to print those who actually which one it's changed, and this is how you can do it. So the angle, this angle brackets, or however you want to call it, will prevent to print the values that the previous position it's not changed. So I don't want to print my X and Y and Z if it's not changed regarding to the previous position. And let's see the result. My Y position now it's correct, so it prints just the Y. Of course, for better, it will be to print in this way. You can do it. It's not a problem. It's just here put some comment with for here, because we have 3 letters of the G code and 1 space. So now let's generate it, click OK, and now it's very, very nice. So what we are also here missing, it's for the pack, it's our Q and F. And here we have like G80, like the end of the cycle. So let's do that right now. The first thing what I would like to do is to close the drilling cycle. Okay, and the reasons how I'm doing it, sorry, not the reasons, but the way how I'm doing it, and also to show you one really, really nice function is the next command and the preview command. It's like our GPP tool will read what is the next procedure or what is the previous procedure. And I know that my drill point, after my drill point, it's coming, you know, the end drill, right? So what I will use here is like next if my next command it's not equal to this drill point, right? Then just print out, you know, in the new block G80, right? And just end if. And that will generate, like, if we are not again in my drill point, just generate G80 and it's end of the drill point cycle, right? Now, what I say here, we are also missing here, it's my depth. And just to speed this up a little bit, we have a down step in our pack drill, right? If I choose here the pack, my data is coming out, right? When I click it here, we are getting like the parameter of down step. And here, because I have here the 6 millimeters, maybe to put here 3 will be pretty handy. And I'll just save it, calculate, and here I can use it. Now, what will happen if the user will put here like 0? That's pretty much not good, because then you will not get the pack, and for the Q0 you'll get alarm message on the controller. So you want to try to prevent the customer to make mistakes. You know, this is from my experience, and trust me, it's better to avoid, you know, the not necessary mistakes, and then later on you'll need to get a post-processor edit. Try to handle as much as possible, you know, before you release it. So let's start like this. So if my down step, right, it's equal to 0. So if the user make a mistake, let's put like down step, it's now equal to 1. Okay, it's like 1 millimeter. It can be like 0.5, but I'll just 1. It's totally fine. And then let's print something to user. Hey, you make a mistake. What I'll put here, pack depth, pack depth is 0. Kali is changed to Q1, okay, or Q1000. It depends on the controller. And that's it. And then we will just print it, no new block, because if I put new block, it will generate it in new block. I want to continue here. So just here, I'll just print. Let's not do it this way. Let's do it more modern, you know, like down step. And then I'll play with my format. So whenever I put semicolon here, you can put your format. And I'll put like Q, and then I don't know, 5.3 here, and I will here multiply by 1000, because I want to get the correct format for it. That's pretty much about down step. And what else it's missing here? Yeah, it's like the feed. Perfect. Let's generate our G code. Very nice. Except here that we're missing the space. But this is how, you know, to handle and to support everything regarding to the drill cycles. So now adding more drill cycles to this is just the job, that you just need to add it manually, and to, the structure is pretty nice. You just need now to add more drill type, maybe to add new parameter that it's very important to you, and so on and so on. Now on next webinar, I will closely work on this. I'll just mention one of the things that I didn't have so much time here, but I'll just put here something more advanced, to the drilling cycles. And today, at last, I'll just talk a little bit what kind of sub-programs actually we can support it. And let me just jump immediately into that. I already mentioned something here from the previous webinar, where I explained it how to work with the subroutines, and how to handle it inside the post. But today I will just show you two different types of what we can actually support it. Now I'll just jump to the working style, and all regarding to the procedures, it's right here. Okay. And here what I have, let's say by default everything will be to no, no, no. Okay. And if you would like to get a procedure and put it to yes, 7 exit, I'll just jump into, let's see, here I have one regular operation, like I mentioned it before, and I'll just generate the G-code. Okay, so let's see how does it work. On the beginning of the program, this is the main program, okay, and I'll just split it. So this is our main program, where somewhere we are calling for the subprogram, right? And inside of that subprogram, it's totally whole operation. So it's pretty good, sometimes, the customer are asking this, so this is the way how you can do it, Now, sometimes there is a need, to create subroutines, right? So if I go to no, here I will just close everything. Now the different way how you can support, the procedures, it's if you put the sub procedure here, yes. If you exit and I recalculate everything, generate the G-code, click yes. Now, here you can pay attention like this. This is our main program, like we have in previous example, but the sub procedure, it will generate the sub programs if you have a repetition of the same toolpath. So here we have one toolpath, then we have the down step, and again repeating, again the same path. So the result is very nice. So we are getting, the subprogram that it covers another subprogram and another subprogram and another subprogram, and it's coming here, right? So it's pretty handy. It's very nice to know it. And now the third option that we are supporting in SolidCAM is to not output all of those subroutines it's in like after the main program, but actually to print it out inside the main program and just call these subroutines, okay, like generated on the job level. Now I'll close it. I'll just jump into the VMID, go to the working style procedures, and here inside the procedures we have like yes and level 1. Now the level 1 only works if the sub procedure is put to yes. Now if I save and exit, you need always to recalculate, okay, in order to get the parameters that we changed to work. I'll generate it now. I'll click OK, and this is what we have here. This is our main program, and inside our main program we have our operation, right? But if this operation has, like we say, much more down steps and so on, it will generate just those steps in a different, at the bottom of the G code. So this is the three basically different ways how we can support it, and this is how actually the VMID parameters about the sub procedures actually works. Okay, I hope that you enjoy, and just on the end, I would like to thank you everybody for your attention. It was a little bit longer webinar, but I hope that brings to you, and your level of the GPP into much higher one, So if Eddie, if there's any questions now, I'm ready to get for the answers. Of course, Daniel, if there's enough time.
Yeah, Daniel, thank you very much for this webinar, for your efforts. There were many questions by webinar chat, but fortunately, through the webinar, with the help of post-processor expert in SolidCAM Ltd, Evgeny Mar, all were answered. Yeah. So guys, also next webinar, those who didn't ask the question, you can chat the question. Yes, just to type the question in chat area and you will receive the reply. So Daniel, all the questions were replied. There were many questions, yes. But again, we received very good feedback about the webinar. One of them very useful and professional. So Daniel, keep the push. Thank you very much. Next week, we will make the last webinar in the series of post-processors webinars. And after that, we will make, as agreed, some kind of summary exam for attendees of these webinars, yes, for those who watch these webinars after that and watch your video lessons and learn our GPP tool documentation. It will be very nice test for you to know that you are able to make basic customization for SolidCAM post-processors. And now, again, thank you, Daniel. And I will not be there with you for the next webinar. I will be in Dallas. So one more reminder that those who will attend SolidWorks World 2016 in Dallas, we are eager to meet you there. Thank you very much, Daniel. Thanks to all our big audience today. And we'll see you next week. Thank you,
everybody.
Thank you.
Bye-bye.